Today we sharpen recurve knives, chiefly fighting knives.
Combat?
Not exactly. Combat is a broad term covering every kind of knife you can see in the battlefield. Everyone will have sort of all-rounder. Fancy name for them is tactical knives. Usually they have oversized handle for a gloved hand. And there are assault knives. So combat knives are like tactical, field, utility, all-rounders, and fighting assault knives. And these fighting assault knives have several categories. There are stilettos for covert operations. In Western tradition, there are straight assault knives like this one. But the most common are recurve fighting knives. Look at this. Recurve edge gives knives certain advantages in fighting. The knife acts well in both thrusting and slashing. And the damage caused by a recurve from a simple thrust is the same damage that with a straight knife will require a slashing action. If you compare two knives of the same length, you will see that in a recurve knife the edge is longer, causing more damage. There is also a category of ring fighters. The ring fighters not only guard your finger, but they also increase efficiency of the card during withdrawal, especially from behind. And of course they assure that you won't lose your knife in the rage of the fight. Many fighting knives have some sort of guard for your finger. And some recurve knives have these sort of tooth in their convex part, convex segment. This tooth increases damage caused in slashing. You can see recurve blades in hunting knives, like this beautiful Muyala. And this actually is an interesting variety composed of two concaves and its smaller pocket brother. The only purpose of a knife like this is assault. They're good for nothing else. So, sharpener sees lots of recurve knives as shaped edges, and sharpening them is a pinnacle of a sharpener's skills because of the complex curves. Let us sharpen this knife. Thanks to the black coating, we will see how the bevel forms more clearly, and it has pronounced curves. In order to get even symmetric bevels on both sides of your blade, the blade must be centered in the knife jig. Unfortunately, Tormek knife jigs, they are not self-centering. Our solution is that we prepared a set of Tormek knife jigs where we milled static clamp. It is all explained on our website, but in brief, an unchanged Tormek knife jig, it fits well and centers blades up to 3 mm thick. Then the second knife jig that has 0.5 mm milled off the static clamp, it accommodates well blades 3 to 4 mm thick. The next jig, which accommodates well blades 4 to 5 mm thick, has 1 mm milled off the static clamp. And the last jig, it accommodates blades over 5 mm thick. For example, we are going to sharpen this blade. First of all, I measure its thickness. Can you show? In this particular case, it is 4.8 millimeter. So I will pick the jig number 3, this one, which accommodates blades 4 to 5 millimeter. And the blade will be almost perfectly centered in the knife jig. Next, to sharpen a recurve, you just have to use a pin pivot collar. They cannot be sharpened using regular adjustable stroke. So we have to remove the adjustable stroke and replace it with the pin pivot collar. Remove the O-ring. By the way, do you see this cloth tape on the jig? When your adjustable strap becomes loose and doesn't hold well as you grind, I just put a layer of a cloth tape to make it tight. Remember, the pins must be perpendicular to the plane of the clamp. Okay. Now we have to select the proper abrasive. Let's talk about that. Selection of the right wheel depends on the steel. Mainstream and carbon steels are sharpened on aluminium oxide, which is your SG wheel, where resistant steels, tool steels will require silicon carbide, which is your black Tormek SB wheel, and where volume of very resistant carbides exceeds 3%, you definitely will need CBN or diamond wheels. For sharpening recurves, we use reduced edge CBN wheels. For example, today we sharpen two ring fighters. This one is by Australian knife maker Adam Parker. The blade steel is K110. It can be done on either aluminium oxide or silicon carbide wheel. The traditional cookery can be done on aluminium oxide wheel. What makes this knife sort of collectible is that it was featured, similar knife was featured in the 1990 movie Tales from the Dark Side, in the hands of a cannibal lady played by the Blondie singer Debbie Harry. When we come to this knife, this beautiful ringed fighter by a Japanese knife maker Kiku Matsuda, the blade steel OU31 has lots of wear resistant carbides. It will require a CBN wheel or diamond wheel. We'll be doing it on CBN wheel. And the knife that we'll be sharpening right now is by a United States knife maker, Daniel Frazee. He called the knife Big, where B stands for bolo, the shape of the blade, and E was what said the first person who saw it. So this beak is made of M690 steel, and better be sharpened on silicon carbide. However, most of beveling I do on this Japanese wheel. This particular wheel is grid 800 jigs, which is equal to European 1200 grid. By the way, do you know what's the most common abrasive in the Japanese traditional stones? No? It's silicon carbide mostly. So when you use a stone wheel, when you use a CBN radius edge wheel, the corner of the wheel is smoothed, is radius. You have to do something similar to your stone wheel. You have to smooth the corners. It is very important to smooth the corners fine. That's because the pressure on the corner, pressure per point, will be higher than when you sharpen flat on the stone, on the wheel. So even if your wheel is coarse, grade the edges of the wheel fine. You can use, for smoothing the corners, the fine side of your Tormek grading stone, Nagura stone, or a diamond plate. It doesn't really matter. Recurves are sharpened on the ends of the wheel, about 1 centimeter wide. The blade goes this way. And the key to get perfect even bevels in a recurve is to sharpen all along the length of the blade at the same line of contact on the wheel. We set line of contact at the most proximal point, which is the trough of your concavity, so it will go like that. We mark line of contact with a laser. Use of laser is optional, of course, but makes the job easier. A variety of laser guides are being used by sharpeners. One of them, this one, the laser holder is attached to your Tormek, and by regulating distance and inclination you set the focus. But I prefer laser guides that are external to the Tormek. It gives me more room and more flexibility. Let me show you one. This is the laser module I prefer. It uses a flexible, adjustable holder. And if you plan to make a laser guide yourself, all you need is some sort of laser module and some sort of holder. When picking a module, a laser module, pick the minimal power that allows you to see the red line clearly. I use 5 milliwatt laser module. Why? Because as you sharpen, let me show you. Is the laser line visible on the video at all? Can you
Yeah,
see it?
quite a bit.
Okay. As you sharpen, there will be reflections of the laser beam from the water and from the blade when it is a polished one, which potentially can be harmful for your eyes, for your vision. The low power red line lasers are safe for your vision even when accidentally viewed directly. We set the line of contact, the laser line, at the very trough of your concavity, at the most proximal point, in this case here. We set grinding angle using our software, but no matter what method you use, let's say you use Tormek Angle Master, set your grinding angle at the very bottom of your concavity. To set the grinding angle using our software, you need to know the wheel diameter. This particular wheel is 247.1 millimeter in diameter. Next, you need to know the jig protrusion. And remember, this is jig protrusion to the nearest point on the edge, which is the bottom of your recurve. So in our case it will be one hundred 141 millimeter. $247.1 for the wheel diameter, 141 millimeter for the jig protrusion, and I will grind at 15 degrees per side. To get this grinding angle, we need to set the universal support at this height, 170.3. Thanks to advice from Dr. Werner from Germany, we now use this depth probe. The universal support height is now set to grind at 15 degrees per side. Having set the universal support height to grind at your target angle, set the laser line at the bottom of your recurve. And now we are set to start grinding. Sorry for the dark video, otherwise I won't be able to see the laser line. Remember that we sharpen near the edge of the wheel, about 1 centimeter wide. Just watch it. By the way, the water stream will show you that you are doing it right. Don't slant the blade too much, just enough to maintain about 1 centimeter wide contact with the wheel. I can feel we've reached the apex. Almost there. One more pass. As I do the last pass, watch how I do the convex segment. Let's see the bevel we've got. Could you switch on the light, please?
This one.
Appreciate even bevel width all along the edge. The other side. Now we can move to the bearing. A recurve blade can be deburred on Tormek leather wheels or on rock hard felt wheels, and on paper wheels I will show you all three ways. When deburring on Tormek leather wheels, we start with the Tormek honing paste. If you run out of Tormek honing paste, you can use Autosol metal polish. They're equal in result. And having finished the first wheel, we then move to the second wheel with Chromax. We control honing angle with the help of our frontal vertical base, and first we have to set the honing angle. Let's see how we do it with our applet. The frontal vertical base has its own software. The diameter of this wheel is 215 millimeters. It's the Tormek new leather wheel. The jig projection, as you remember, is 141 millimeter, and the honing angle is 15. degrees per side. Seven 3.9. Not sure if you can see it. Okay. Have to do it twice. Can you change the wheels? Clean the blade. I use low water tubs, turpentine. The sharpness we get on Tormek leather wheels using this method is what people call scary sharp. On the best scale it is near 100, 90, 100, like that. Which of course is arm shaving. And you get better sharpness using paper wheels and felt wheels. It depends on the steel. Let me clean the blade and then we will do a few sharpness tests. $75. 75 is insane sharp by our funny classification. Let's check the concave segment. $105, which is scary sharp. Haven't got much hair. Can you see my hair?
Yeah.
On display. Can't see anymore. What normally people cut? Magazine paper?
Yeah, magazine.
Okay, let's see if I've got some good step back later. Let's cut this one. I'm not sponsored by Aldi, unfortunately. How do we cut? Like this? What else?
What can we cut?
Cardboard?
Yeah.
This one is a tough one. Let's see what we can do. Wow. Well, it is okay to hone mainstream stainless knives or better quality knives that have small amount of vanadium, cobalt or molybdenum, usually under 0.5%, even up to 1%. These knives is okay to hone them with aluminium oxide and chromium oxide compounds. These little amounts of alloys are added to enhance hardness of the chromium carbides and this way improve the edge retention. But where a blade has a significant volume of wear-resistant carbides, like this OU31 steel, it must be honed with diamonds or CBN to get the best edge retention. It is all explained in my knife deburring book, available for free on our website. If you haven't read yet, it has a section on high-end knives as well. On felt wheels, I sharpen high-end knives. Felt wheels are preferred to use with diamonds because they retain the diamonds on their surface way better than any other substrate, and consumption of your diamonds suspension is lower. Usual segment for sharpening high-end, wear resistant knives is like that. Could you show? We start with 6 micron diamond suspension. Then I change the rock hard felt wheel to another wheel and continue on 2.5, 3 micron diamond suspension and finish with half micron diamonds. Let me just demonstrate how I do that. Before I do, if you don't have 3 rock hard felt wheels, if you've got just 2 of them, you can skip the middle step and do 5 micron first, finish with half micron. Alright. We control honing angle with the same frontal vertical base and software that we showed you. And so on. The last third method is using paper wheels, which we will show you now. Honing on paper wheels, we control the honing angle using our software for paper wheels. We use our controlled angle supports and this application. We are going to hone on 8-inch grinder with 10-inch paper wheels. So I selected this option. We'll be doing it on the right wheel. The right wheel diameter is the application. Remember this, the last value I entered. So 90.8 millimeters should be the height of our paper wheel support. And that's how we are going to set it now. Now we are setting the honing angle to 15 degrees. And so on.